Yeah, so thanks for showing up this evening, everyone. My name is MacDonell, and I'm a veteran PyCon attendee, first-time speaker. The talk I'll be giving this evening is called The Breakup, Monolith to Microservices. So just by show of hands, who here is writing code for a monolithic application? I am too. And who here is developing microservices in production? And who here wants or is in the process of breaking up a monolith into microservices? So talking to the right crowd, I guess. So I'll be doing some storytelling today of how I've experienced such a breakup in my past few years of working at a startup in Munich. So first, just a bit about myself. You might have noticed my last name is Scottish, but I'm sure my accent gave away that I'm from across the pond. I was born and raised in a small town outside New York City on Long Island. Nowadays, I currently live in Munich, Germany. After graduating from high school, I went to college with the intention of studying physics. But in my second year on a whim, I took an introductory computer science class, became hooked, and switched my major to computer science. In college, I learned to code mostly in C. Anyone seen this article? It's a good one. But I also learned quite a bit about OCaml. Those of you who aren't familiar with OCaml, I guess it's like this European car. My experience has been a programming language for people who find Haskell too mainstream. But it's pretty cool. When I graduated from college, I moved to Munich to work at a startup as a back-end Python developer without having any Python experience before. In case you can't read the caption, it says, Python is great for everyday tasks, easy to drive, versatile, comes with all the conveniences built in. It isn't fast or sexy, but neither are your errands. And I think this last part is a bit of an unfair assessment because coming from C and OCaml, Python was, to me, pretty magical. So 2 years later, I'm still a Python developer at the same startup, and I'm going to tell the story of how, what our experiences were like breaking up a monolith, the challenges we faced, things we learned, and some Python-specific tools we found helpful for our own microservices. So the company I work for is called Stylite. It's a content and commerce company. So what does that mean in practice? The content here comes from the online lifestyle and fashion magazine, and the commerce is the platform to shop for clothing and home and living products. So basically, Stylite earns its revenue from our partner shops through a cost per click, also known as the CPC compensation model. So for a product that might seem at first like the antithesis of a nerd culture, we are a wonderfully nerdy tech and data-driven company. We have a very young and international culture with about 170 employees, about 45 of whom are engineers, coming from 23 different nationalities, and our business language is English. Stylite was originally started in 2008 by 4 students continuing one of their university projects. 2 of the co-founders came from technical backgrounds, so it was decided that one would work up building up the back end while the other would work on the front end, the website. So jump forward 6 years later, when I first joined Stylite, the company had grown to about 80 employees, and this back-end application had grown into a monolith called Core, which was being worked on now by about 10 developers. So when I recently looked up the definition of monolith, I found a couple of variations, which each highlighted the key problems they can cause. The first definition points out immutability, massiveness, or uniformity. And the second definition considers a monolith to be indivisible and slow to change. So what exemplifies these points for us from a technical perspective? Immovability. Although we want to use Python 3, it would be a crazy amount of work to port all that code to Python 3. Massiveness. There are over 1 million lines of code in the core repo and the database with over 300 tables. Uniformity. We don't have much choice between the tools that we use, and we are resistant to experimentation. Indivisibility. The monolith more often than not lends itself to spaghetti code, and even if we want to cut out code into bounded contexts, we have software that depends way too much on those several essential helper functions, and we often deal with other type coupling between various parts of our application. slowness to change, the monolith is simply non-agile, and we want to deploy fast and often, but often we find ourselves waiting over a half hour for Jenkins to test someone else's changes before we can merge and deploy our own. And when one small change failed the test, then we were all blocked from deploying. Precisely, here are the main symptoms of our monolith: huge number of lines of code, long test suites, and 2 pizzas couldn't feed our team. So, anyone heard of the 2 pizza team? Okay. This comes from the Amazon founder and CEO Jeff Bezos, who created the rule that teams shouldn't be larger than what 2 pizzas can feed. And just for the clarification, they're American pizzas. Maybe not that large, but yeah. But simply, however, for me as a new and inexperienced developer, this monolith was incredibly overwhelming during onboarding. To make even one small change to the code meant that the whole application would need to be tested and redeployed. And in this way, it sometimes felt like a house of cards, that just one misplaced card would bring down the whole stack. So aside from the technical aspects, however, core necessitated learning the ins and outs and jargon of every domain of the value chain, from business management of shops to product feeds and product processing to performance marketing and SEO. Being separated from these business teams often meant poor communication, and increasingly more of the feeling of you versus us. But about 1 month into my job, something surprising happened. One day we came to work and had a company-wide meeting, and we were told that effective on this day, we would be working in cross-functional teams. These autonomous cross-functional teams were created around a different business focus, each made up of people from different backgrounds and areas of expertise. In practice, this meant that most every team has a product owner, at least 2 engineers, and often designers, data scientists, and various other managers with expertise in the team's business domain. Having dedicated engineers on each team meant better resource allocation for the needs of each team. So at this point, I'll just make a quick aside to briefly introduce the concept of microservices. By a common definition, microservices are considered to be small, independently deployable services built around specific business capabilities. Now, although microservices appear to have become, in recent years, the cool new thing in software development, it's not necessarily a new concept. The canonical example for this is the design principles for Unix. As you can think of the utilities as having singular purposes, but you also have the freedom to combine them to do more complex tasks, like FineCube capture. In 2014, Martin Fowler and James Lewis published their seminal article on microservices, in which they attempt not to define this architecture, but rather define common characteristics shared by such architectures. I won't go through all these, but if you have time to read this article, I'd highly encourage you to do so. So what do the cross-functional teams have to do with microservices, you might ask? Besides being the latest cool startup trend, the move to cross-functional teams was in the attempt to make teams smaller, to make our 2 pizza teams. We wanted these smaller teams because we saw that there are several problems that arise as the size of the team grows. The first and most obvious issue is that communication gets worse with every new addition to a team. If you consider your team as a number of links between people, you can easily see how much more difficult communication is to manage. A less obvious issue, however, is that people generally become overconfident as the size of a team grows. In the agile setup, for example, this might often lead a team to underestimating the complexity of their tickets. A study at a Lego factory, in fact, shows that 2-person teams need, on average, 44% less time to build the same Lego figure than 4-person teams working on the same tasks. So aside from the desire to avoid more difficult communication, there was also the wish to improve communication. So I borrowed this slide from one of my colleagues, and I'm sure you can deduce the meaning of the diagram, even if you don't speak German. So a bit corny maybe. But all jokes aside, it really hits the nail on the head for the miscommunication issues we face. Within the former setup, the engineers ideally needed to be well-versed in the jargon of several different business domains, yet in practice, it often meant that the overhead in each sprint of meeting first to go over terminology again and again with stakeholders, and being physically separated from these stakeholders, us in our tech bubble and them a few rooms or floors away, meant that it wasn't so easy to ask questions and get clarifications on the fly. Finally, with regard to this organizational switch, there was the hope that a certain phenomenon would emerge, namely Conway's law. Melvin Conway was a computer scientist who in the 1960s coined the law: organizations which design systems are constrained to produce designs which are copies of the communication structures of these organizations. So it's a mouthful to say. So more simply put, the design of your system will mirror the way your organization communicates. But was this reverse engineering of Conway's law really going to work for us? Can you just change the organizational structure and respectively these communication patterns, and then expect the monolith to naturally break up into microservices? The answer was for us, yeah, it's not that easy. And there were a few reasons why this didn't work perhaps as quickly as we thought it might. First off, the communication structure didn't really change overnight. There were real pains of separation for the engineers. Although I was only there together with these guys for a month, many of them have been working together for 3, 4, 5 years in this so-called tech bubble of the company. Many of them were truly one another's best friends. This then meant that although we were now sitting with designers, POs, and various other business people, we were still getting coffee with the other engineers, still mostly writing messages to one another on the engineering Slack channel. Essentially, all of our communication patterns weren't changing all that quickly. Secondly, lots of dependencies. As I mentioned, core was spaghetti code with lots of type coupling. It was difficult to determine exactly how to nicely pull out the common code that we needed. We realized that we would need to make separate libraries for all of this code shared by different cross-functional teams. But then the question became, who wants to do that grunt work, and who is ultimately responsible for these internal shared libraries? Thirdly, there's simply a barrier to entry to creating a microservice when it hasn't been done before. We were just now becoming familiar with cloud computing with AWS, and all the work of our platform engineers was still a bit mystifying to us. With regard to microservices owned by teams, Amazon has the notion of you build it, you run it, where a development team takes full responsibility of the software in production. To be perfectly honest, engineers weren't jumping up and down about the idea of now going on call with new services with the possibility of being woken up at 3 a.m. in the morning. So clearly Conway's law wasn't going to be the single magic bullet for microservices. So we set out about dealing with each of these challenges. To deal with the dependencies, we began pulling out our commonly shared code into internal Python libraries running on an internal PyConUK server, which included libraries for storage, database helpers, CloudFormation stacks, text processing, logging, etc. Our common dependencies in core can now be versioned and imported by our new independent services. Additionally, we wrote boilerplate code as a Python project template for our services, which included config support with DynamoDB, basic Docker setup, and invoke tasks to test with PyTest, and build and deploy using CircleCI. By forking from this repo, we were then able to get microservices up and running in a few minutes, and then we were able to customize based on the particular technical needs of the service. So now at this point, from a technical stance, we have a feeling that we've made it over the first hurdles of the breakup to microservices. As for the initial pain of separation for our engineers, we soon, of course, made new friendships with our new teams, and having these diverse teams meant that we had these new vertical relationships with our new teams and horizontal relationships within our disciplines. To maintain our horizontal relationships, we borrowed an initiative from Spotify called Guilds, in which people of the same discipline voluntarily gather on a regular basis to touch base on higher level topics within the organization, but also to develop within their own disciplines. Within our engineers, for example, we have guilds for test-driven development, agile practices, and data science. In regard to our vertical relationships, cross-functional teams have enriched us with knowledge from many new disciplines, from DevOps to design, as well as the business savvy of our own particular team's mission, whether that be business development or finance or performance marketing or search engine optimization. So I myself work for the SEO and content services team, and our team's mission is to bring more organic traffic to the Stylight website, as well as facilitate the supply of content to our online magazine and shopping search pages. Here's a short timeline of the key events that have happened in our Monolith breakup story. So as you can see, December 2014, we have the 2 engineers that moved into the cross-functional SEO team. March 2015, SEO-related data is moved into its own Postgres DB. December 2015, so a year later, that's when we first make our initial microservice. It's called the Similar Search API, and it's being, at this point, consumed by the website team. March 2016, we get 2 more engineers and create a separate AWS account for our team. And today we have 5 independent microservices, no reliance on the core database. Rather, we retrieve data from other teams' internal APIs, but we still have UI and a few jobs still running in core. And at this point in the company, several other teams were also working at similar velocities. And for a stretch of a few months at Stylight, we had a so-called API mania, in which all of our teams with engineers made a real push toward our microservices goal. And to be honest, it was a bit of a draining experience in some ways, especially for product owners who, while they were briefed on the value of these services, couldn't really feel any explicit business value in these efforts. But as we've gotten past the end of API mania, product owners are definitely beginning to realize the value that we have through the autonomy of our software and freedom to make changes and make those changes really fast. Now if we look at the Stylight website, you can see that for all the yellow boxes outlined here, there are different APIs from various teams that are providing the data for those sections. So 2 years ago, we had a front-end database that provided all the data here. And now the front-end database is incredibly slimmed down and due to these new internal APIs. So I'd like to now showcase one of our APIs as it highlights iterative steps we took away from the monolith and the array of tools we were able to use in building up this microservice. So if you look to the left side of the page here, it's a bit difficult to see, I guess, but it's a widget for similar searches based on what a user has searched for on the page. So in this case, it's dresses, and we give similar searches there. This was, in fact, our first microservice as a team. And of course, one of the appeals for us of moving to microservices was that we could, of course, finally move to PyConUK. This meant, however, that we needed to make some of our internal shared libraries compatible for both Python 2 and Python 3. Here we were really helped out by the Python library 6, which provides tools for writing Python code compatible for Python 2 and Python 3 versions. Additionally, we use talks to automate testing in different Python versions. After dealing with these compatibility issues, we were ready to get going with our new shiny Python 3 service. These similar searches are determined by a fairly complex algorithm that our SEO managers developed, which takes into account data from Google Analytics as well as various dimensions of user value. In our first iteration of the service, we still did all the calculations as a scheduled job in core, although writing to our own database. And the new service simply provided a thin facade between the data in our database and the website. In this case, the facade was a RESTful API using Flask. So in case you aren't familiar with Flask, it's a Python micro framework, a so-called micro framework, as it's a very lightweight web application framework. And in fact, we've used Flask for all of our microservices so far and have been quite happy with it. As for the use case of this service, the website will make a request to our endpoint with a given URL. In other words, the website says, give me all the similar searches for the URL. Mental dominance, so codes for women, and we then provide the similar searches as JSON data. And you might be asking yourself, what's really the big deal here? It seems like perhaps a lot of work for a small functionality, right? Well, in this case, we were saved from having to write this data into the website's front-end database, and thus we avoided an integration through the database. We also wrote up an explicit contract with our website team in which we defined allowed methods and request parameters, as well as the structure of the response. So there are many tools out there, of course, for writing API documentation and contracts. Although we haven't completely standardized on one tool company-wide, we're mostly using Swagger to write our specs, as it requires only a simple YAML file and is language agnostic. And while most of our company's services are in Python, we do have a few in Java and Scala. Nowadays, when we roll out these services, rather than API documentation being an afterthought, our first step is usually to write up a Swagger file and sit with the API consumers to discuss the contract specifics. We found that doing this as a first step before starting often firms up the expectations of the service. The website team then integrated our API, but as you might imagine, latency became an obvious initial issue. With approximately 30 million URLs in our database, the database queries for requests were simply taking too long. Additionally, we have sites in 15 countries throughout the world, so even despite some caching magic from the website team, the latency of requests to our API hosted in Frankfurt were simply taking too long. To improve our performance, we switched to storing our similar search data in Redis databases to allow for super fast lookup. To do so, we added an endpoint to the API to make post requests to periodically sync the Redis database with our Postgres database. We also at this point decided to host the API regionally in Frankfurt, Virginia, and Sydney, with local Redis databases in each location. These measures brought request response times down to about 50 milliseconds. As you can imagine, the major advantage of having such an API layer between the data and the website without a database integration meant that we could make these backend changes without having to modify our API contracts at all. So at this point, the website team is pretty happy with us. We brought latency down to a negligible amount, but then a few months later, our SEO managers think, wouldn't it be great if we could update our similar searches more frequently? In core, the computations for similar searches for 30 million URLs took an embarrassingly long 3 months to compute. Our dirty secret. So now we can bring that down to a few weeks. It was time for us to move our current job out of core into the microservice. This meant adding background jobs to our service. In our case, we've used Redis Queue to queue and dispatch jobs to workers, and the RQ dashboard to monitor our RQ queues, jobs, and workers in real time. To then scale better on our computations of similar searches, we realized that we would need to scale with more parallel computations. After some experimentation, AWS Lambda turned out to be a great tool for this use case, allowing us to scale up to 500 parallel computations. You can do more than 500, but you have to get approval from AWS, so we're working on that. So this has allowed us to bring our computation time down to about 2 weeks for these 30 million URLs. We're using the Apex library to build and deploy our Lambda functions, and we found it really easy to use for managing all of our Lambda functions. So versioning. With the most recent changes of our service, plus some other cosmetic changes, we wanted to roll out a new version of our API. Versioning is often an FAQ when it comes to microservices. For us, we simply maintain 2 endpoints, one for each version that passes V1 and V2, for example, and remove the former once it is no longer being consumed. In terms of logging, we use AWS CloudWatch, and more often we use the AWS Logs command line tool to get some more readable output of these logs. We're currently using more of a bare bones approach, still experimenting with tools for logging. If any of you were at Becky Lewis's talk yesterday, I think she gave some great examples for logging tools that we'll try out as well. For monitoring of our services, we have PagerDuty with a rotating on-call schedule. There are different escalation policies based on the criticality of the service. At the lowest escalation, we receive emails, and at the highest, we receive calls to our mobile phones at any time of day or night. It doesn't make sense, for example, for us to be called at 3 a.m. if the similar search API is down. Instead, the website should be handling this issue by not displaying the widget. However, one of our other services, which supplies the articles of the online magazine, is much more critical. And because we don't want to tarnish our relationship with our loyal magazine readers, we want to keep our downtime here as low as possible. So now I'd just like to leave you with some final thoughts from our continued journey to microservices. We haven't yet reached a happy conclusion with this breakup. We're still dealing with several topics, including deciding on who owns what data, whether we should really be so strict about the rule of having one database per microservice, also standardization of documentation styles company-wide, and also the discoverability of services within the company. So while it's been clear for us to see the advantages of microservices, it's impossible to claim that microservices is a one-size-fits-all solution. Poorly written code in a monolith won't automatically become elegant code in microservices. And there isn't a correlation between the number of microservices and the robustness of a system. For us, it's been important not to lose sight of the reasons why we broke up the monolith in the first place. And with that, at the end of the day, we can say we've learned a lot from this journey, and as Martin Fowler sagely said, we're cautiously optimistic about the microservice future. If you're looking for a job and are excited about microservices, Stylight's hiring for a really, really good software engineer, that's your job title. Otherwise, feel free to get in touch, and thanks for your attention.
lightning talks. I won't get up because anywhere I stand, I will be standing on someone. So, does anyone have questions for Julie?
Yeah, I just wondered what happened with the core, the ownership of core.
Yeah, so it's tricky. We all, like all of our back end cross-functional teams co-own core. It's, to be honest, we're still so far away from it not existing. There are things that don't really have a specific bounded context that we can go into as a microservice. And we're trying to avoid the thing of just breaking up the monolith into like dumping ground microservices. So we're still struggling there, but I'd say.
With your microservices all owning their own data, thinking of your business intelligence group, do they then query your microservices, or do they separately aggregate all that data together in their own little?
Yeah, so I can speak from the experience of my team that they have a microservice that we send data to. It's not an ideal solution, I'd say. But they're not working so much with the data that my team owns, to be honest. But for example, we need to access quite a bit of data from our product processing team. And there's some places where we can get that on the fly and use it. But a lot of times we have to resort to like caching into our own database for these pieces of data. Just because it takes too long otherwise to do. And then you run into we're also experiencing some struggles with this async type of data storage system as well, I'd say.
User service discovery is still under discovery.
Yeah.
Do you have initial thoughts on that?
Well, so I just saw a talk by Kevin Goldsmith, who is the CTO of Spotify, and at Spotify they have this, I think it's called Zookeeper, where it's a website that all the engineers can go to, and it's a list of the services, and it links to GitHub repos and various other information about services. And so we thought maybe like we have this thing at Starlight called Ship It Days, where we spend a day once or twice a year hacking away at anything, and we were thinking maybe for our next Ship It Day we'll put together a website, an internal website like that, where we could put all together our services so it's easier to discover.
Yeah. When you're using Redis for sharding with like, read-only data, what other options did you consider? What do you think might work?
Honestly, I think we went straight to Redis on that one. Yeah.
I've got a recommendation as well. Have you tried 5D and D?
No, I've never even heard of it.
Try them.
What's it called?
The D programming language and 5.D.
Okay, cool.
If you're language agnostic, it might be.
Cool, thanks.
You mentioned Flask and Vectoid. Do you
what was the second one?
Flask and Vectoid as a website?
Yeah.
So do you not like pre-band it with like Nginx or something?
No, I mean, so we have Nginx for like. To be honest, I'm not the best person to talk to about this part. The DevOps stuff is not really my specialty. But I think so. We have Nginx with like our Docker files, so that helps put together with Flask. But I'm not quite sure there, to be honest. Yeah.
So you do use Vectoid for sending responses back to clients?
Sending.
Well, so you get a response from the client, so that probably is fronted by Nginx, but then for the internal web service, you still use Vectoid.
Yeah. Mm-hmm.
I think lightning talks are just about starting downstairs. So, thank you.